Bollinger Bands are a technical analysis tool used by investors and traders to assess price volatility and identify potential buying and selling opportunities. It was developed by John Bollinger in the 1980s. It consists of three lines plotted on a price chart. Middle band, a simple moving average, SMA of the security price, typically over a 20-day period. This can be adjusted. Upper band, two standard deviations above the middle band. Lower band, two standard deviations below the middle band. Regarding the breakdown of some key interpretations, please refer to my website. The link I also attached in the video descriptions. There are many approaches to creating Bollinger Bands in Power BI. We can leverage the built-in run R script functionalities or create customer functions within Power Query Editor to generate the three bands. Alternatively, we can use the customer DAX formulas. Even with the DAX formula approach, we have two options. The reason is that the calculations of SMA and standard deviations require time window size. Default is 20 days. These requirements indicate that we will only get more accurate calculations for the two indicators after having 20 data points. Thus, the first trick is how to handle the early missed 20 data points for calculating the first 20 SMAs and standard deviations. This kind of how-to methods lead to approaches, either to assume initial values for the first 20 data points, or just wait for until we have enough rolling 20 data points. Another trick is time window size itself. The 20 days should represent a trading days, excluding weekends and holidays. Thus, for the calculation on how to find out the valid rolling 20 date range with identified dynamic maximum date and a dynamic minimum date from the stock price table is crucial. In this video, I shall share the approach on how to use a DAX formula to create the three Bollinger Bands without initial value assumptions. Okay, let's get started. In the sample Power BI desktop file, in fact table, multiply stock data MACD EMA DIY, we have columns date, stock code, close price. These data are required for our calculations. Stay at the data view. On top ribbon, choose Home or Table 2 tab. Click New Columns. Let's first calculate the middle band and name the column name as middle band DAX without initial value. First, define four variable holders for the current date, target stock code, the window size for SMA, and the standard deviation multipliers. Secondly, let's build a data range table according to the current date and the target stock code. Thirdly, find the numbers of the data points from the filtered table data range by DAX function counter loss. Then find the earliest date, or we also call the minimum date from the data range table if it is a raw number is larger or equal to the window size variable. By combining DAX function MINX and TOPN. TOPN lists 20 data points from a data range table by descending date. Then use MINX function find the minimum date from the sorted TOPN list. Otherwise, ignore all other scenarios. Just assign the current date as the earliest date. Fifth, filter the table data range once again according to the found minimum date and the current date. So the return result of this step will be either a 20-row size table or a single-row size table. This is a crucial result we achieved so far in the whole DAX formula. Now we can calculate the indicator SMA by just checking the found minimum date from the last filtered data range table. If the minimum date is the current date, then assign 0 value to the SMA. Otherwise, we calculate the simple moving average of a closing price from the table filtered data range which has 20 raw data points. Finally, we return the calculated vendor size SMA value to the column measure middle band. Check formula. A middle band value appears in the new created column. Now copy the whole DAX formula and create the new column. Paste the DAX formula and name it as upper band DAX WOI. In the formula, we need to add the calculation of a standard deviation, which will be used to build upper and lower bands. Same logic as we have calculated SMA, but using DAX built-in function StdEvx.s, which is a sample standard deviation. Finally, calculate the Bollinger upper band and return the value to created column measure. For lower band calculation, we just slightly modify the DAX formula of upper band by subtracting 2 times standard deviation from SMA. That is all about in this video regarding the DAX formula creations. Place the 3 calculated Bollinger Bands into the visual. We can start our stock price analysis with other combined tools, such as a candlestick tool. Thanks for your watching. If you like to watch more videos from my channel, please press subscribe button. See you in next video.